The first step is to gather data to be used as parameters when running the Comcot model. This data is obtained from the IRIS database to search for tsunami event occurrences that will be visualized. The selected event is the Aceh tsunami disaster on December 26, 2004, caused by a 9-moment magnitude. After inputting the earthquake event, proceed to the IRIS event page to obtain more detailed information about the 2004 Aceh earthquake. The next step is to access the moment sensor page. Here, you will find information about latitude, longitude, depth, magnitude, strike, deep, and rake, which will become parameters in the Comcot model. Longitude and latitude are the coordinates of the earthquake, while depth is the depth of the earthquake epicenters, and magnitude is the energy released by the earthquake. Strike is the orientation of the fault plane relative to north. Deep is the angle of the fault plane's inclination. And rake is the relative movement of rock blocks separated by the fault. After obtaining data from the IRIS database, retrieve data from GAPCO or GEBCO, General Bathymetric Chart of the Ocean. GAPCO provides global seafloor topography information, which is crucial in tsunami modeling as seafloor topography affects tsunami wave propagation. There are of interest extend from Aceh to Africa, aiming to determine the impact of the Aceh tsunami on the African continent. After gathering all the necessary data, configure the comcot.ctl file in the Comcot model. This file sets various parameters and options needed for the tsunami simulation, including simulation duration and output interval. Configure the fault model parameters using data from the IRIS database, such as focal depth, strike, deep, and flip. Input parameters like length and width of the source area and fault plate dislocation require specific calculation based on earthquake's magnitude. Prepare the previously downloaded GAPCO data, which is in the .tif format, for a predefined area. Convert the GAPCO data from .tif to .xyz using a MATLAB script to prepare it for input to comcot.ctl. After converting data file to the .xyz format, move it to the same directory as the comcot.ctl file. Then, input the .xyz file name in the comcot.ctl configuration under the layer 01 file name of the bathymetry data section. Fill in other parameters in layer 01, such as x, fill in with start and end, at y, fill in with start and end, and also the origin of computation. Fill in with longitude and latitude in the fault model section. These parameters are obtained from the comcot_1.nlp file created during the conversion process. Run Comcot using the previously input parameters. Comcot will read the parameters, including general information, fault model, grid layer, and bathymetry data in layer 01. The following segment displays Graphanes monitoring tools. showing server performance during the Comcot run. The CPU widget indicates increased usage when starting the Comcot process and decrease upon completion. Running Comcot generates timestamp output files in .dit format. As we seen here, there are three consoles. The first one explains about correlation between two nodes of HPC. The second and the third one explain about parallel computing software. The software that explained here are WineAPI and Slarm. Visualize the .dit files using a pre-prepared MATLAB script. Each .dit file produces .png image representing timestamp every 60 seconds. Combine these .png files into a GIF file format for a final visualization of the tsunami using the Comcot model. This visualization illustrates the impact of the Aceh tsunami on surrounding countries, including Sri Lanka, India, the Maldives, Madagascar, and the African continent. The tsunami reached the African continent approximately 8 to 9 hours, or 28,800 to 41,000 seconds after the earthquake occurred in Aceh.